Hello and welcome to Google Cloud Next 2022. This session is maximizing your open source investments with a truly unified experience using Apache Beam. My name is Sachin Agarwal. I'm a group product manager in data analytics here at Google Cloud. We've got a very simple agenda for today's session. We'll talk a little bit about Apache Beam, and then we'll talk about Beam on Spark, Beam on Flink, and Beam on Cloud Dataflow, and making the right decisions for you, your organization, and your business and technical needs. Let's get started by doing a quick overview on Apache Beam. Apache Beam really comes on the last 15 to 20 years of innovation and experience around big data processing. In January of 2023, Google published the MapReduce paper, which was then adapted by engineers at Yahoo and became externally available as the Hadoop project. Internally at Google, we quickly ran into limitations with MapReduce and replaced MapReduce with something we called Flume. Flume allows for the creation of a pipeline of MapReduces and deferred execution to allow for optimizations. The original Flume Java paper was published by Google in 2010. Millwheel, again from Google, was our original way to do low latency streaming and deals with persistent state, the continuous flow of records, and provides fault-tolerant guarantees. The Millwheel paper was released in 2013. At the same time, the initial Spark project started in 2009 at UC Berkeley's AMP Lab, which has now evolved into the existing RISE Lab at UCB. Spark entered incubation at the ASF, the Apache Software Foundation, in 2013, and became a top-level project on February 27, 2014. The initial Flink project started at Stratosphere as a collaboration of 3 German universities in 2010. Flink became an incubator project in March 2014 and became an Apache TLP in January 2015. So you can see that Spark, Flink, and Beam all ended up being produced at roughly the same time, with Beam being a little bit after. Beam was put together as a practical approach to balance correctness, latency, and cost on both unbounded, which are streams, and bounded, which are batch data sets, with a particular focus on strong resiliency for out-of-order data sets. The Dataflow model paper was released in August 2015. So Spark was originally started in 2009, Flink was originally started in 2010, and then the beginnings of the Dataflow model started in 2015. Beam actually evolved from that paper with help from Cloudera, Data Artisans, Talend, Cast, and PayPal, and became Apache Beam in 2016. It was an incubating project at the ASF in February, and then became a top-level project on January 10th, 2017. So the vision for Apache Beam was this. What if we took the lessons learned about big data processing over the past decade, had a singular API for both bounded and unbounded data sources, included a wide variety of sources and sinks out of the box, made it easy to reuse our existing infrastructure while also providing the ability to innovate with purpose-built execution engines. And then on top of that, made it super easy for developers to get started by having the widest variety of JVM and non-JVM-based language support. So that's what the Apache Beam team did. Apache Beam has a single API, included Beam IOs, a wide variety of runner support so you can swap compute in and out as your needs change, and continue to add new languages. Let's get into how Apache Beam works with an example. In this example, a developer writes a pipeline in the language of their choice. Generally in Beam, a basic pipeline has a P collection, or a collection of elements, and at least one P transform, or a compute function. In this example, you can see that the input brings in the P collection, and this pipeline's P transform is called sum per key. The sum per key is a so-called combiner in Apache Beam. Combiners are built on a group by key primitive, and for many types of common operations, a combiner offers performance advantages when processing large amounts of data. Sum per key applies the group by key primitive in the Java language. So here you have this very basic pipeline. That pipeline is then executed in the Beam runner of the developer's choice. So any language and any runner, that's the essence of what we call portability of the Apache Beam model. Then you can leverage your existing Spark clusters to execute these Beam pipelines with the portable Spark runner. There's also a portable Flink runner, and you can see some other niche and experimental execution environments such as Spark, Samba, RAID, and Dask for these Beam pipelines. So Beam is made to leverage your existing investments. It's truly universal with a unified large-scale batch and streaming data model. It's completely developer-friendly because of the included IOs and the various SDKs. And it's portable, allowing you to run Beam pipelines in the execution environment of your choice. Your existing Spark clusters are a wonderful place to get started exploring Apache Beam. So let's talk a little bit about Beam on Spark. So with Beam on Spark, you can use your existing Spark clusters or any existing Spark environment to run your Beam jobs. Some of the benefits of rewriting existing Spark jobs into Beam jobs for execution on the Spark clusters include these unified batch and streaming and combined pipelines. But please do note that Spark does batch processing much better than stream processing. There are fewer lines of code than Spark code when you're writing Apache Beam, especially for these batch processing jobs. And you can write Beam code in Python or Go when using the portable runner for Spark. To learn more, please go to beam.apache.org/documentation/runners/Spark. Here's an example of Beam on Spark at LinkedIn. This was a talk from Beam Summit 2022 in Austin, Texas. The LinkedIn team uses their Spark clusters to run batch pipelines and uses their SAMZA clusters to run their streaming pipelines. But it's all the unified Beam model, so their developers and their engineers only have to learn how to write Beam code, and then other teams that manage the infrastructure run the infrastructure on their behalf. No one has to worry about those implementation details. You can see a link to the YouTube channel and to this particular talk of Beam on Spark at LinkedIn at the URL provided. I mentioned Apache Flink as another execution environment for your Beam pipelines. Let's talk a little bit about that. So Flink is a great option for self-managed stream processing computation. And the benefits of running Beam on self-managed Flink clusters can include that Flink is very good at streaming or continuous processing, whereas Batch has some limitations to run on Flink. It's the inverse of the benefits and drawbacks of running Beam on Spark, which is why many organizations run both Spark clusters and Flink clusters to run their Beam pipelines. This is really ideal when you need to upgrade from batch to streaming based on your business needs, when you need to move from overnight or cron jobs to real-time computations, but you still have to self-host your compute environment. Again, you can write your Beam code in Python or Go when using the portable runner for Flink. And learn more again, beam/documentation/runners/Flink. And here's a great example. The folks at Lyft write in Apache Beam and use their Flink clusters for the execution environment. This is a great case study for you to read. You can take a look at it at beam.apache.org/case-studies/Lyft. Now let's talk about Beam on Google Cloud Dataflow. Dataflow was built from the ground up to be the premier Beam execution engine. Remember, we started off with the Dataflow paper and then moved into open source as the Apache Beam project with our partners at PayPal, Data Artisans, Cloudera, and others. On this table, you can compare your options to pick the best execution environment for your needs around cost, performance, and operational overhead. Some example considerations to look at are execution correctness and quality. Again, we talked about batch on Spark and streaming on Flink, security, ease of use, observability, and the speed of performance. We really encourage you to get started with Apache Beam by taking advantage of what you already have and what you're familiar with. And then as you and your organization really learn to take advantage of the power of the Apache Beam truly unified model, find the right execution engine for yourselves. So thank you so much for your time joining me to learn about maximizing your OSS investments with Apache Beam. Please check out the other on-demand sessions here at Next to learn more about Google's Data Cloud.